This session is for OCR FP2. The topic is Maclaurin series, and we're doing question 2 from January 2011. So let's just start by reading the question. So it says it is given that f of x is equal to tan to the minus 1 of x, and we're asked in part 1 to show that the third derivative of f of x is equal to 2 upon 1 plus 3x squared over 1 minus x squared all cubed. And then in part 2 it says hence find the Maclaurin series for f of x up to and including the term in x cubed. So part 1. So we are given that f of x is equal to tan to the minus 1 of x. And we will now need to differentiate the first time, and we get 1 over 1 minus x squared. Now you can look that derivative of the inverse tan, you can look up in your formula books. I'm going to write that as 1 minus x squared to the power of negative 1, and then use the chain rule to find the second derivative. So the second derivative is going to be, well, it's going to be a negative there, and then we're going to be multiplying by a negative 2x, so that's going to give us a plus 2x upon 1 minus x squared to the minus 2. So at this stage you could use the product rule, or alternatively you could write it as a fraction and use the quotient rule. So it's really a matter of choice, but I'm going to use the quotient rule. So we're going to find the third derivative now using the quotient rule. So it's v du by dx, so that the derivative of u, the top line is 2, so that's going to be 2 lots of 1 minus x squared all squared, and then it's minus u dv by dx, so that's going to be 2x times the derivative of all that, which will be negative, so there's going to be a plus sign, and you're going to have a 2 and a 2x, so that's going to give us 8x squared upon 1 minus x squared. So I'll let you just check that differentiation there, and that's all going to be over v squared, which is 1 minus x squared all squared. And then it's going to be squared again, so it's actually to the power of 4, that's right. So what we need to do now is just try and simplify this top line and see that in actual fact there is a common factor of 2 lots of 1 minus x squared, and we can take that outside the brackets, and inside the brackets we'll get a 1 minus x squared from that first term, and then we'll get a 4x squared from the second term, and that's still over 1 minus x squared all to the power of 4. So if you have a quick look at the top line now, we can see that we can divide through by a factor of 1 minus x squared, top and bottom, and then that will leave us inside these curly brackets. We have 1 plus 3x squared, there's a 2 outside, so we now have our result. So that's the result that we were trying to establish. So if we just have a look at how the marks are allocated, there were 5 marks for that question. So there was 1 mark just for getting your derivative of the inverse tan, a method mark. There was an accuracy mark for doing this first bit here, finding your second derivative using the chain rule, and then there was a method and an accuracy mark here for using the quotient rule to get as far as this stage, and then another accuracy mark for making sure that you have it in the correct form. So 5 marks in total for that particular bit. So if we have a look at part 2, so I've just written down all what we've just found in the correct form, and then we're going to be using Maclaurin's theorem. Now remember that Maclaurin's theorem again is in your formula book, so f of x is equal to f of naught plus x f dash of naught plus x squared over factorial 2 f double dash of naught, and so on. So what I'm going to do over here is I'm just going to go through and find f of naught. So when x equals naught, the inverse than of naught is nothing. When x equals naught, f dash of naught will then be equal to 1. When x equals naught, that means the second derivative is going to be naught, and then the third derivative, if we put in naught everywhere, we'll get 2. So using Maclaurin's theorem then, than to the minus 1 of x will be, so remember the first term is x, so f of naught, which is going to be nothing, and then so the first term is going to be x, because we have one lot of the first derivative when x is naught, and then the next term is going to be 0, and then we're going to have two lots of x cubed over factorial 3. And we're only asked to go as far as that, that's a factorial, and so if we simplify that, then factorial 3, the 2's will cancel out and we get x plus x cubed over 3. So there were 3 marks for that question. And again, if we just have a quick look at how those marks were awarded, then you got a B mark, statement mark, for just getting these first 3 correct, and then you got a method mark and an accuracy mark for finding the value of the third derivative when x equals 0 to be 2 and substituting it in carefully into Maclaurin's theorem. So 8 marks in total for the question. So don't forget, if you want to do further revision videos, then just go to the Further Maths Support Programme website and you'll be able to follow the link.